Start with understanding the client side connect time, load balancing and failover configuration. Now this concept applies for client machines. Now when a client connects in, especially in case of a rack where you have more than one instances running from different servers, your client may get connected to the database either from node 1 or from node 2. Ultimately what a client is interested in is getting connected to the database and not whether he is connecting in from instance 1 or from instance 2. We can make a provision here for the client to provide multiple choices for listening locations. Now since in our configuration that we are going to talk, let's first try to understand the setup. So this is how our setup is looking like. So we have server, RDBMS server, which is on Oracle 2 and Oracle 6. This is the rack configuration. So we have a database here running on both these hosts with the name RackDB. The name of the instances, the one that runs on Oracle 2 is RackDB1 and the other instance for the same database is running from Oracle 6. The name of the instance is RackDB2. So since we have two different hosts, we also have two different listeners. Name of the listener is listener underscore Oracle 2, which is using protocol TCP and port number 1521, which is running from Oracle 2, and there's a other listener Oracle underscore 6, listener underscore Oracle 6, which is running from the host Oracle 6 itself. Protocol is TCP, port number is 1521, and they are actively listening for RackDB. Now for us to understand how one listener can be aware about a remote listener, you must have followed our earlier video for listener configuration, where we talked about a listener can run locally on the same host or can also run onto a remote host. So let's understand this setup first. So here I have some commands: host name, the platform, the Oracle home, the Oracle SID and the status of the listener. So all of them in one go. So currently I am on to Oracle 2. The platform that I am on is Linux for Oracle 2. The Oracle home is itself set for 10G RDBMS, U002 APP Oracle product 10G RDBMS, and the name of the SID is the name of the instance RackDB1, and I am checking what is the status of the listener on this host Oracle 2. So I can see the name of the listener is listener underscore Oracle 2, and currently it is aware about a service with the name RackDB2, which has got instance RackDB1 currently ready for accepting the connection, instance RackDB2 currently in a ready state for accepting a connection. I could verify the same thing from the other host. So here the host name is Oracle 6. The platform that I am on is Linux for Oracle 6 host. This is my rack enabled RDBMS home. Oracle seed however is set to RackDB2, and the status of the listener should suggest that my listener is aware about the existence of both the instances. So if I move on to LSNR CTL status output a little further, I see this particular section. So this listener is also aware about a service called as RackDB, which has two instances, RackDB1 and RackDB2. Both are in a ready state for accepting connections. So how our listeners are aware is via the file or parameter remote listener. Why there is no value for local listener? Is because the listener anyways is running on 1521 and the protocol anyways is TCP. So I don't need to categorically mention that what is the value for local listener, since PMON by default will do a dynamic service registration if a listener is locally available and is a default listener. So I am more worried now about not about a local dynamic service registration, but only with a remote dynamic service registration. So only the parameter remote underscore listener points to a TNS entry. Now if you explain further what is this TNS entry looking like. So this TNS entry goes to the VIP address of Oracle 2 and VIP address of Oracle 6. I will come back and revisit what this VIP stands for in case of Oracle. So we are going to the virtual IP of Oracle 2 with port number 15 on port number 1521 and the protocol being TCP. Same for Oracle 6-VIP, port is 1521 and protocol is TCP. So that's where my PMON process is going to go and do a dynamic service registration. Now because of this parameter is in place, each listener which is running on to Oracle 2 and on Oracle 6 is aware about the remote instance running on each other's host. So that's because of the dynamic service registration. So now we want to understand how my client machine, let's say which is Oracle 3, is going to have a TNS configuration in place so that it can have a choice either to get connected from a listener which is this one running on this host, or get connected via this listener which is running on this host. So let's configure our client machine which is this one. So our client machine is Oracle 3, which is again a Linux machine, and this is the RDBMS home from where we need to configure the TNS names. So I go and open the netmgr utility to configure my listening location. So I go to local service naming. So far no service has been defined. I go and type in any name that I would like to test this. So I am saying test rack. I am making sure that I select the correct protocol that my listener understands. I am mentioning in the name of the host where the listener is available. So listener is running on to Oracle 2-VIP as we confirmed it here. And on to Oracle 6-VIP. So I mentioned in the name of the host. If this name is not or name cannot be resolved, you can also put in the direct IP address of that particular Oracle 2-VIP. So instead of putting in the name, if you find it difficult to resolve it by name, you can put in the IP address. Port number where that listener is running on the given host is 1521 and the name of the database. So I am using the service name instead of instance name. But now if I look into the entry, I have just provided one listening location. So let me save this one, come out of this utility and go to the location Oracle Home Network Admin. This is how my tnsnames.ora looks like. But now here I can make a provision to add another address as well, because I can get connected to the rack database either using the listener which is running here, or I can give myself another choice. I can also go to the same database by requesting a connection to a listener which is running on another host, that is Oracle 6-VIP. I can directly hand edit this file, but since this is not the supported one method, I am going to re-invoke netmgr. And now I add a second listening location. Here I mention the other endpoint where the other listener is running, giving the details 1521. I save the configuration, I get back to my command prompt, and now I say, let me show you how my TNS names now looks like. So now I have two choices. Either I can get connected to RACDB by making a connection request to a listener which is listening here, or by making a connection request to a listener which is running here. Both the listeners are aware about the available instances for the database RACDB. The available instances for the database RACDB are so instance 1 RACDB1, instance 2 RACDB2. I could have added one more column. So this is how our setup looks like. So I have instance 1 with the name RACDB on Oracle 2. Then I have instance 2 with the name RACDB2 which is running on to Oracle 6. If I see what's the name of my database, so name of the database is RACDB2. So I go back to the client machine and now I try to see what's exactly happening. So one of the listener is running on to Oracle 2-VIP on port 1521. The another listener is running on to Oracle 6-VIP on port 1521, and I am requesting a connection using service name and the name of the database. I am not using instance underscore name. I am saying the name of the service rather than specifying Oracle seed. So I have connected to by providing the service name as the seed, instead of seed as service name. But now the problem here is, although this is how my connection entry in my tnsnames.org or net service descriptor looks like, the problem with this entry is it will always try to select, when I say from my host, it will always go to this particular entry. It will never consider the second entry. So I must make necessary provisions to randomly balance this load. Now assume that I have given this TNS entry to the 1000 clients that I have in my network. So all those 1000 clients, when they connect in by saying SQL plus user name / password @ this TNS entry, so all of them pretty much will connect to this listener only, since this listener is first on the list. So while the other listener is waiting for connection request, this would be overburdened by accepting too many connections from the newly connected clients. And although I have a second listener here, that listener is idle because nobody is connecting using that second address. So that's the problem with this type of a setting. So I must explain it to the client that from the available choices, I call this as choice number 1 and this as an choice number 2. So from the available choices, randomly select either this one or this one. So I am adding in a parameter to my to my TNS names.aura, which says load balance is equal to on. So from the available choices, it will randomly select either this address or this address. Now assume that I have all 1000 connections defined with the parameter load balance equal to yes. So some of them would then select option 1 and others would select option 2, and this happens randomly. So it's not on round robin basis. So a client may either select option 1 or option 2 if I put in this line to my TNS names.aura. So what I am effectively achieving by putting this line, that all the connections are not being requested from listener 1 only. Now the load is getting randomly balanced at the connection time, because some clients will go and make a connection request here, other clients may go here and make a connection. So our earlier problem with this TNS entry, that everyone is going and banging their head against this listener, is reduced. So we will effectively utilize both the listeners by putting in this line load underscore balance equal to yes. So I go to here and I select the advanced connection option of this thing. So far what is my correct thing? Try each address in order until one succeeds is the current setting. So this indicates when I am using first option, this indicates off and failover is equal to on, although it is not mentioned. When not mentioned, it's on by default. For load balance, when you don't mention it, do we have a load balance parameter defined here? No. So when you don't mention it, then the by default setting is off. So it is as good as saying load balance is equal to off. That's what we need to understand. Try each address in order until one succeeds. So all the clients will try this address first, and I assume that we have a valid listener here. So since there is a valid listener here, all of them will go and connect to option 1 only. So are you effectively utilizing the listener which is at this location? No. Until what point you are not utilizing it? Until this particular listener is brought down. So all of them will always go to option 1. They would use option 2 only when option 1 is not reachable. That's what we are saying here. Try each address in order until one succeeds. Until one succeeds. So that's what failure is equal to on. So try in order. So try first. Is it successful? Then you are connected. If it is not successful, then try in order. the second one. And if I am talking about a 8 node cluster, there would be 8 such entries here. So what we mean by default configuration is load balance is off and failover is equal to on. So when you don't mention failover, failover is always on. When you don't mention load balance is however off. Let's try selecting the other entry that is available. I am deselecting this so I get more choices. So 8i and onwards, all these choices were available. Now see what if I select this one. Try each address. How? Randomly until one succeeds. Meaning on and on. So let's try to save this setting. Now let me go to and show you what is the impact of we making the changes from the front end. Clear? On or yes means one and the same thing. So load balance is equal to now on. Failover anyways is on, whether you mention it or don't mention it. However, you can categorically turn off failover by saying load balance is failover is equal to off. So this is what I mean by saying try each address but try randomly until one succeeds. Now when the client connects in by providing username using this TNS entry, now the TNS entry I am going to pick up the modified one. So all 1000 clients who has got this TNS entry would randomly select between option 1 or option 2. Now assume that first client who got connected selected option 2 and option 2 listener is available. So you will get connected using option 2. Now second client who is connecting in, he also applied the same randomization logic because load balance is equal to on and selected this as the first option to try. Now are we not effectively utilizing both the listeners? Yes. In this case we are effectively utilizing both the listening locations. Try one address selected at random. So what we mean? Try one address means load balance is equal to on but failover is equal to off. Because what we are saying here, try only one address but select that address randomly. So failover is off because we are trying only one address, but load balance is on since your selection is random. Let's save it. Try to obtain the new TNS names.ora setting. That's what we said. So load balance is on and failover is equal to off. Let's try the next choice. Use each address in order until destination is reached. Now this is something which is used in a special case. Now we are talking about a new parameter source route. This only is used in a particular case, and that particular case is when someone uses Oracle product called as connection manager, or to be precise CMan, which is for the current discussion out of scope to discuss. For the time being, this is an other product which Oracle provides called as CMan or connection manager. Currently we are not talking about that product or how to implement that product. That product people use for firewall settings, and for routing a connection through a centralized utility called as CMAN. However, that's not the point of discussion for the current session. Then I categorically go and select use only the first address. Are you using load balancing? Are we using failover? No. So let's save this one. So in this case you will see a different TNS names.ora. So categorically failover has been set to false. We are not talking about load balance, so what will apply? Default value, and default value is anyways off. So that's what we mean by advanced connection settings here. However, the preferred ones are where both is set to on. So I am selecting try each address randomly until one is successful and save this one. So this is what is our desired setting going ahead. So what do you expect in TNS names.ora now? Failover is equal to on, or even if you don't mention it's on also, or always. But what we want to categorically see is load balance equal to on. So load balance is on, failover even if you don't mention it is always on. So this is the desired setting what we want to see. Clear? So now client would either go to listener 1 or to listener 2. That's what we understand by client side connect time, load balancing and failover. The purpose of load balancing, why we mention load balancing? Because we don't want to burden only the first listener in the client's choice list in TNS names.ora. For that purpose we define load balance. What we define failover for? We don't want to give up connection request until we run through all our choices, is what we use failover for. Otherwise, if you categorically set failover is equal to false, then it will only try first address, and if you are unable to connect through that first address, it will give it up, saying I am unable to connect. But the default behavior for failover is on, so it will try first, second, third, fourth, and only when none of them is reachable, then only it will give up. And load balance is for what? Because we don't want to burden only one particular listener. So we say let the client randomly decide where they want to get connected. Now this is a random decision making by the client, so it's not in a round robin fashion. So if 1000 connections are connecting it, you may not expect 500 as a equitable load distribution for listener 1 and listener 2, but you may see something like 700 are getting connected through listener 1 and other 300 connections are going through listener 2. Clear? So this is what we wanted to see. So let's establish how we prove this thing. So let's establish a method where we can collect the statistics, because until it is proved I am not happy. we are interested in the statistics available for RACDB. So before I could start any of the testing, I would make a note of all these statistics. Same thing, I would make a note of all the statistics from the other clustered node. So this is from node 1 for RACDB1 instance. So far how many connections were established? For RACDB2 so far how many connections are established? So this is from listener 1. From listener 2, which is on Oracle 6, how many of them are established so far? So far nothing. I am trying to pick up the relevant section of this particular output so we can capture and compare where the listener or the request is going in from. So that's it, pretty much we have all the statistics ready. Let's try to initiate a connection from the client. Before I do that, we want to make sure that our files are in place. So load balance is on and failover is anyways on. So my client makes first connection attempt. Possibly the host IPs are not resolvable. So let me verify, can I resolve them? That's why it is complaining. So let me put in the IP address in my etc host file. I believe it's because of we using underscore, and in the configuration file we are talking about let's see what is the correct name. Correct name is dash instead of an underscore. So let me correct my local names resolution method by putting in correct entries. I think the IP addresses are still incorrectly mentioned, or the resolution is still not happening. So Oracle 2 is here, Oracle 6-VIP means this IP address. We will verify it on the client side. So it is still erroring out, saying Oracle 2-VIP is still not, looks like a resolvable one. Let's see why it's not able to resolve it. So Oracle 2-VIP is going here. Is it the correct IP? 192.168.0.11. So here I see a catch. So that's where the IP addresses are not matching. That's why it is unable to resolve them. Now it's able to resolve the IP addresses. So now I am saying go to VIP, and now I also corrected the IP addresses. Now let's try connecting in. Now can you tell me where it is going to go? No one can tell, because client will randomly decide whether to go to listener 1 or through listener 2. Will determine it. So I got connected. Now I go and check the statistics. So I go to the first listener. I try to locate the relevant entry. So this is what I get to see so far. Now I go to second listener, try to obtain the relevant entry. So my connection was made through which listener? The listener that is running on Oracle 6. Let's try one more time. Client has randomly decided where to go. I go and verify the output from listener.ora. Listener's services output. Locate the relevant section again, because there are too many options here. Established 0, established 0. I go to the second one. Established 2. So client is randomly picking from one of the two entries. Let's try doing it for, so we tried 2 times, both times it went through listener which is running on Oracle 6. Now instead of doing it, we will keep on doing it repeatedly. Once, two, 3. So I have connected for 3 more times. Let's try to obtain the status. So total how many connection attempts we made so far? 5 times. Out of which how many came to listener running on Oracle 2? 1 and 2. So total 3 went via a listener running on to Oracle 2. And 4 of them went through listener running on to Oracle 6. So this proves a point Now you may wonder that why there are more than the one that we have made for. So that could be because of instance pinging each other for service registration as well. To obtain the status, it will keep on pinging each other as well. But this proves the point that client is randomly selecting either from option 1 or from option 2. This is what we wanted to see by saying client side connect time load balance. So now all of them are not going to listener 1 for sure. Some of them are going to listener 1, at other times some of them are going to listener 2. So that way the client is offloading some of the burden onto listener 1 and some of the connection attempts to listener 2. So that's what we call this concept as client side connect time load balance. So that's it what I wanted to talk about from TNS names perspective. So this is in short what we have covered in client side connect time load balancing and failover.